I'm going to go over how to solve for the sides of special right triangles. And the first problem we have is a 45, 45, 90 triangle, and it has a hypotenuse of 1. And I'm going to solve for x and y. So the first thing I'm going to do is look at this triangle and think about that it's isosceles. And I know it's isosceles because I have two congruent angles. And then I'm going to think back to geometry and think about what do I know about isosceles triangles. And if I have two congruent angles, the sides opposite those angles will also be congruent. That was the converse of the base angles theorem. So I right now don't know what x and y will equal, but I know they're going to be the same. Okay, now I'm going to think about what I know about special right triangles. And I know for a triangle that has two angles with 45 degrees, the leg times the square root of 2 will equal the hypotenuse. And now I'm going to substitute in the values we're given. Let's first start by just solving for x. X is one of my legs, and I know my hypotenuse is 1, and I'm going to multiply that times the square root of 2. So now to solve for x, I want to divide each side. Well, I'm going to just copy this down first. X times the square root of 2 equals 1. And now to solve for x, I'm going to divide each side by the square root of 2. And now I have x equals 1 divided by the square root of 2. And now I want to rationalize my denominator. Now we need to rationalize the denominator. And in the denominator, I have the square root of 2. So to make sure I don't have any square roots in my denominator, I'm going to multiply the square root of 2 over the square root of 2 because that's just a form of 1. And if I multiply something times 1, I'm not actually changing the value. That's why we can do that. So now we're going to have x equals the square root of 2 over 2 because the square root of 2 times the square root of 2 will just be a 2. Square root of 4, which simplifies to 2. Okay, so now we found x equals the square root of 2 over 2. And we said at the beginning, x and y will be congruent because of the base angles theorem, or actually the converse because we knew the angles first. So now we know that y is also going to equal the square root of 2 over 2. Now we are going to solve for this 30, 60, 90 special right triangle, and this one also has a hypotenuse of 1. So the two formulas we use for any 30, 60, 90 special right triangle is the short leg times 2 will equal the hypotenuse, and then the short leg times the square root of 3 equals the long leg. And I like thinking of them as short and long and then writing down the words and formulas. There are other ways to do this, but here we can use substitution. So first thing we need to do is determine which is short and which is long. And now I'm going to think back to geometry and think about the shortest side of a triangle is opposite the smallest angle. So I have a 90-degree angle, a 30-degree angle, and a 60-degree angle. 30 degrees is the smallest number. That's opposite y. This will be the short leg. That leaves us with 60 degrees being opposite x, and that's our longer leg. And these are just referring to the leg, not the actual longest side, because we know of any right triangle that would be the hypotenuse. So now I can use substitution like we did before, and I know my short side here will be, or the shortest leg will be y times 2, and that's equaling 1. So if I solve, I will have divide by 2, and y will equal 1/2. So our shortest leg of this triangle is 1/2. That's our y value. Now I can use that to figure out x, to solve for x. So now I'm going to substitute that value in for 1/2 times the square root of 3 will equal x. And to multiply these together, that's like saying the square root of 3 over 1, which will be the square root of 3 over 2, equaling x. And we have just solved for x and y.